Hi, this is Ross Mahorter. I'd like to present our position paper, The Randomizer Community Does PCG Research. This is joint work with my advisor Adam Smith and my brother Peter Mahorter. I'd like to begin by reiterating the land acknowledgement from the previous presentation as a way of acknowledging the native peoples on whose land we worked. So to start off by explaining what a randomizer is, here are Ivan and Andy playing the A Link to the Past plus Super Metroid combo randomizer at Summer Games Done Quick 2019, which was a speedrunning charity event that raised over $2 million for Doctors Without Borders. The combo randomizer is a program that alters the games A Link to the Past and Super Metroid by changing the locations of items within the game world. And you can see here that Andy is picking up some rupees in a heart container for Legend of Zelda within Super Metroid. Now, the challenge here is that while the algorithm has to determine item locations within the game for each item, it also has to make sure that the players can eventually complete the game because neither of the players have played this particular arrangement of items before. Generally speaking, a randomizer is any kind of algorithm that takes as input an existing game, an RNG seed, and potentially some settings, and produces as output a randomized game and some kind of spoiler file detailing what changes the algorithm made to the game, and also usually how the player is expected to complete the randomized game. For the A Link to the Past item randomizer, the thing that's changed is where each item drops within the original game, which in turn changes the way that the player has to explore the game world. However, in general, the set of things that can be changed by a randomizer is just limited by the imagination of the randomizer developer. For the most part, the output games are played on the original hardware, which for A Link to the Past means the Super Nintendo from the 1990s. And the spoiler file helps convince the player of completability and also helps the player get unstuck if they get lost while playing the seed. So there's a couple of important ways that randomizers differ from existing uses of PCG, either in academia or in industry. For one thing, they're creating new experiences within existing games. So, for example, a lot of the PCG literature about Mario uses a clone of Mario to, show off how the generation works. For randomizers, it's important that they alter the actual original game and then it runs on original hardware. Furthermore, randomizers are actually pretty competitive. While a lot of people do play randomizers casually, a lot of the focus is on these large scale tournaments where people compete for actual cash prizes. And, as a result, play at a really high level. It's very difficult to get good enough at a randomizer to play in these tournaments. And that's a really different phenomenon than PCG being used to generate single levels in a video game. Another aspect of randomizers that separates them from a lot of academic or industry applications of PCG is that instead of generating a large body of distinct objects that the player experiences sequentially and aren't necessarily generated together with each other, randomizers generate an entire game world, and players often play that single game world for hours. For example, in the previous video I was showing you, those two players completed the game almost 3 hours into the play session. Finally, rather than designing the game around an existing PCG method, instead, randomizers have to design a PCG method that's going to be interesting or work with the specific game that's being randomized. But randomizers aren't just an interesting application of PCG methods. Instead, they actually contribute to a lot of questions that are relevant to the field today. For example, coherent large-scale world generation is a really important problem that exists in PCG right now. And randomizers do coherent large-scale world generation. I think there's a lot of other ways that randomizers can contribute to the academic PCG community. One thing we struggle with sometimes is getting people to actually use PCG in their games, and I think randomizers are a good demonstration that even for games that were never intended for use with PCG, PCG can actually help reinvigorate the game community and, bring out people who would otherwise never have played that game, even without involvement from developers at all. Another concern people express about adopting PCG methods is reliability, and it's true that some of the academic methods have trouble scaling up to the kinds of game worlds that people want to create. However, randomizer developers have been able to successfully create a program that can reliably make completable game worlds for high-stakes races with hundreds of viewers, even though the game worlds are quite large, and nobody has ever seen the content before it is played. I feel strongly about this because understanding randomizers and developing randomizers has been really important for my own research. So about 2 years ago, I developed a door randomizer for Super Metroid. A lot of my work right now focuses on formal analysis of large game worlds, but the expertise that I developed while creating my randomizer has actually been immensely useful in academic research. Furthermore, the connections that I made while doing that have inspired future research projects, but also enabled me to do a lot that I wouldn't have been able to figure out on my own. For example, extracting level data automatically from Super Metroid, which required help from other people with more domain knowledge than I had. So based on what we've been talking about, the first conclusion that I want to draw is that randomizer developers are actually doing PCG research. For the most part, they're not academics, they're not writing papers about it, but if they were, PCG Workshop would be accepting those papers. Randomizer developers are contributing answers to longstanding research questions that are still unresolved, and are envisioning new ways to use PCG that haven't been imagined before, such as in competitive racing. Trying to be a well-read and diligent PCG researcher involves keeping up with a large body of non-academic work. I would argue that that body of work should increasingly include randomizers. Finally, I think there's room for a really powerful collaboration between the PCG research community and the randomizer community along a lot of different axes. Randomizer techniques aren't particularly well documented or studied, and there are existing academic methods to do some of the same things, so comparing those things is a great place to start. I think another important effort is reaching out to randomizer developers and using their domain knowledge to improve our research capabilities. One example of that would be extending VGLC without having to go through the same painstaking process that Adam Somerville et al. Had to go through when they were originally creating the database. Another big opportunity is creating randomizers or creating libraries that help create randomizers rather than investing a lot of effort in developing a new research game every time we want to test a concept. The burden of developing research games has made it harder to move past some of the old standbys of PCG like Mario and Mega Man because there's already such good infrastructure in place to support those games. Finally, existing randomizers can provide a really important source of data, both of how humans play games, how humans explore games, but also just kind of like an infinite library of competently developed games that are hard to complete, but that an AI could theoretically play. So those are some of the ways that we envision the randomizer community and the PCG research community supporting each other. This is the end of the talk. I hope at this point I've convinced you of 3 things. 1, simply that randomizers are pretty neat. 2, that randomizer developers make progress on PCG research questions, and we should work with them to understand randomizers more. 3, that it's not too hard to imagine that the type of collaboration with the randomizer community that I'm suggesting could make your research easier, create new projects that wouldn't have been possible before, and finally, let your work have a larger impact, like reach more people because of the wide audience that randomizers have. Thank you, and I'll take any questions you may have.